Okay, so we're going to review exponential functions. So here we go. So an exponential function has the form of y equals a times b to the x. The a value is called the initial value. It's also the y-intercept of the graph. And b is what we will call the multiplier, or the growth rate at which the function increases or decreases. Note, the independent variable, so the x must be in the exponent for a function to be an exponential function. Okay, that's a really important point. Even though this function, y equals x squared, has an exponent, it is not exponential because the 2 is not the input. The base is the input. So for this to be exponential, I have to switch places with the 2 of the x so that it looks like that. So multiple representations. We've talked about this, so it's important to look at this for exponential functions. So in the examples I'm about to show you, in each representation, the y-intercept is 0, 5, and the growth factor is 2. And the growth factor is going to be 2 because in each instance, the y value of the functions in each representation increases by multiplying the previous y value by 2. So here's this. So as you can see, here's my initial value of 5. So that's my y-intercept. And the b value in my equation is 2. So we got y equals a times b to the x. So that fits all those things. Okay. The next one, okay, we got the table. So one vocabulary word I will use is this idea of a step. So if I go down from, if I increase my x value by 1, that's a step. Okay. So every time I increase a value of x by 1, I'm taking a step. So look at this. So to get from 0.2625 to 1.25, I multiply that by 2. To get from 1.25 to 2.5, I multiply by 2. And I can keep doing that, right? If you go from 2.5 to 5, multiply by 2. You can see how each time I go up one step, I'm increasing the output by 2. So on a table of an exponential function, the amount I increase the y value by via multiplication should correlate to the multiplier value of that function, 2. You can see right here, when x equals 0, right, that's my y-intercept. And you can see that I have a value of 5, which correlates to the 5 in the equation. Now let's look at the other one, is the graph. So here's a graph of this function. If you note here, this here is the 0.05, right? And so if I did this, so this right here, I'm going to draw a line. That right there is 1. So you see how from 0 to 1, if that's 5, this point should be 110. You can see as the x value increases by 1, the y value is increased by multiplying by 2. So at any point on a graph, I should be able to see that. Okay, last thing we're going to talk about is percent increase and decrease. As you go through this course, most of these problems dealing with exponential functions and models will describe situations where a quantity is changing by an increased or decreased percentage. So let's just define this. Exponential functions model situations in which a quantity or value changes by a percentage over a constant period of time. Percentage of change is denoted by the multiplier of the function. So So I'm going to talk about percent increase first. So to increase a quantity by a percentage, add the percentage to 100% and convert to a decimal. So say I have something, let's say money, and my money increases by 3.2% every month. So to find the multiplier for the function, I take 100%, add that by the increase of 3.2%. That gives me 103.2. I convert that to decimal by moving it to decimal 2 places to the left, right? So 1, 2, and that's 1.032. So that would be my value for B in my equation. Now to decrease, I do the same thing, but I subtract from 100 the percent I want to decrease by. So again, let's decrease by 3.2%. So I take 100% minus 3.2%, that's 96.8%. I move the decimal twice to the left, I get this. And so in this case, this would be the B value for my problem. So, so say I started with $100 in each of these cases, right? If I'm increasing my money by 100, my model would be Y equals $100 times this percent as a decimal to the X. This one, say I'm losing that much money a month. So it would be $100 times this decimal value to the X. That's how I'd write those models. And again, just the thing is the final decimal value, so these values I calculated once I took my sum and difference of percentages and converted them to a decimal, that is going to be the multiplier of the value of B for the function.